Hello everyone. This is a quick video just to kick off Module 7. Module 7 is going to be on multiple regression analysis. So what I'm going to do is just run a real quick recap of what we did last week in Module 6 and then talk to you a little bit about what we'll be doing in Module 7. Last week we picked two variables from the Boston housing data set. We picked variable RM, which represented the average number of rooms in a neighborhood and houses in a neighborhood. And we picked median value, which was the average median value for all of the houses in the neighborhood, or the median value, I guess I should say, for all the houses in the neighborhood. We tried to show how the average number of rooms can be used to predict what the median value is likely to be in that particular instance. So we ran linear modeling in R to figure out or find the slope and the intercept. The slope, of course, is going to be what shows the amount of change, and the intercept is going to be where we cross the vertical axis. Once we have those values, we built a model where the median value was equal to the intercept plus the average number of rooms times the slope, And we were able to predict the values for the median value. We were also able to show the error. The problem is we got quite a bit of error. It was a pretty high amount of error. And so the error is really an indicator of our model. And we have the advantage of being able to determine what the error is because we can compare what the actual values were to the predicted values, and the difference is always going to be the error. Sometimes it will be higher, sometimes it will be lower. But when you look at the amount of error that we got, when we calculated the median value for those neighborhoods, it was pretty high in some cases. And if you look at it as an overall assessment of the model, it means the model is not that accurate. And that's going to happen from time to time unless our variables that we're comparing, the predictor variable and the output variable, are fairly tightly correlated. We're going to run into a situation where we're going to get a lot of error. So we're not quite where we'd like to be. And the solution to that is to either find variables that are more closely correlated, which you don't always get to pick the variables that you want to work with, or we can turn to something called multiple linear regression. Multiple linear regression is where instead of using a single variable to predict an outcome, we use multiple variables in conjunction with each other to predict that same outcome. So when we use regression to predict likely outcomes, we can either just use one variable, as we did with our example from Module 6, but we're likely to have more error. So imagine if we could use more than one variable as a predictor, and imagine if that made our model much stronger and much more accurate. An example from our previous module could be, instead of just using the average number of rooms to predict the median value, what if we used, in conjunction, the average number of rooms and the tax rate? We would get a single intercept and we get two slopes. So our single intercept is still the one coefficient that shows where our trend line is going to cross the vertical axis. But our two slopes are going to be split, for one for the average number of rooms and one for the tax. So the equation that we would set up then would be our median value would be equal to our intercept plus RM times its slope plus tax times its slope. The slopes are really actually called coefficients, so we'll probably move away from calling them slopes to calling them coefficients, but I'm just using this to illustrate the example. You can have more than two variables in a multiple linear regression model, and when you do that, every variable you include as a predictor is going to have a coefficient that represents its slope. And in the example that I'm going to give you in Module 7, we actually use three variables. Well, we initially use three variables, and then as part of the exercise, I have you take one of them out. So if we have selected wisely, and we've selected multiple variables that are actually good ones to be predictors for our output variable, then we're going to get a much more accurate model, and we'll have much less error. So for this week, I've got two external videos that I've posted from a guy by the name of Brandon Fultz. And Brandon Fultz has an entire series out there on YouTube that goes through all different aspects of statistics. And he does a really good job. Now, the only thing about the Brandon Fultz videos is they move a little slow. So if you're feeling uncomfortable with the idea of multiple linear regression, don't worry, because Brandon Fultz will really seriously, step-by-step, methodically walk you through it. If you're feeling like you get to a place where you're a little confident, then they can seem like they drag on a little bit. But they're definitely worth watching. He has other videos that follow in the series, so he has like an entire series of regression videos. And I think it goes in a different direction that I don't really want to talk about don't think it's necessary for our purposes. So I only required you to watch the first two, but I think you'll get quite a bit out of the first two. After you watch those two videos, I want you to come back to the Canvas course and watch the fourth video, this being the first one, Brandon Fultz being number 2 and 3. The fourth video is the one I posted, and that video is going to walk you through your exercise. I've done something similar. I've given you a data set. The data set is a Toyota Corolla data set, and I've also given you an R script. So I'm going to have you load up that R script in R, and then I'm going to walk you through it step by step. And I'm going to explain what each of the steps in the R script is doing. And it's important that you pay attention to that because your job is going to be to go in and make modifications to the R script and then produce the results, drop those into a Word doc, and submit those as your assignment for this week. But don't worry about that until you get through the Brandon Fultz videos and then you get to this video. I will give you one thing of note. I recorded the video for video number 4, the one that actually talks about your assignment, goes through the script. It's a good video, and I've done a lot of work on it, but I recorded it for the last time I ran this class. And the last time I ran this class, things were done in different order. So it is going to make reference to a textbook that you're not using, and it's also going to make reference to the fact that it thinks it's Module 6, when in fact this is really Module 7. That's just at the beginning in the first couple minutes of a 30-minute video, so go ahead and ignore it. If I get an opportunity, I'll go ahead and re-record the video. So if you see the video and the video doesn't do that, that's because I had time to re-record it. But I'm going to go ahead and post it now for those of you who want to work ahead. And you can go ahead and just ignore any references that are made to a module or a textbook that we are not using. Okay? Let me know if you have any questions, and I will look forward to seeing what you come up with. Oh, one more thing that I want to talk to you about, and that's a couple of definitions. I'm going to go over these right now in this particular introductory video because I think Brandon Fultz uses these in his video, and I just want to be clear about the terminology that we're using. So some of it's going to look familiar to you already, but I'll go through it anyway. From statistics, p-value. P-value is typically the chance that the results you got were purely by chance, or it's basically a measure of how meaningful were your results. The actual meaning of p-value is, if you had a null hypothesis and your null hypothesis turned out to be true, what's the chance that the results you got would happen if your null hypothesis was true? Don't worry about that. Look at it from this perspective. If you got a p-value that is greater than or equal to a certain number, and that number typically is 0.05 when we're dealing with social sciences and most sciences. Hard sciences can sometimes be 0.01. But if you get a p-value that is greater than that, then probably you have too much error in your calculations and you really shouldn't trust your results. So he will talk about p-value, so just know that that is a measure of how much really can I trust my result. He also talks about error, and we've talked about error already. Error is the difference between the predicted value and the actual value. And it's when you have the predicted and actual values you can calculate your error. It's often shown in a regression equation, or shown in a regression equation. So it was there when we calculated the linear model with RM and median value, and our equation becomes y is your predicted y is equal to your intercept plus your predictor variable, which is x. In this case, that would have been RM, times slope plus error. So you'll often see linear regression equations being set up just this way: y equals intercept plus x times slope plus error. And that's how we calculate the actual y value, not the predicted, but the actual y value. You'll get through some of that in the Brandon Fultz videos, as I had indicated.